In this video, we're going to talk about how to write two-step story problems. Let's go ahead and get started. Maya bought some books. She spent a total of $58 after a discount of $7 of her total purchase. Each book cost $5. How many books did she buy? So let's get a little mental picture. So Maya went to the store. She bought books. They cost $5 each. She went up to the cash register. They gave her a discount of $7, and then she ended up paying them $58. Okay, so that's the story of what happened. So let's go ahead and write an equation for what is going on. So let's talk about what she spent. So she went into the store and she did what? She bought books for $5 each. So if she picked up one book, that'd be $5. If she picked up two books, that would be 5 plus 5. If she picked up 3 books, that'd be 5 plus 5 plus 5. Now, because I don't know how many books Maya picked up, I am going to write the equation 5b. Okay, because remember, addition is just repeated addition is multiplication. This right here would be 5 times 3, and that represents the number of books she bought. So 5b represents how much she's going to spend on each book. Now here's a little key feature. If you see the word each followed by a number or with the number $5 for each book, that's a key that I'm going to have a variable there. So 5b, I already knew that was going to be the case. Now she got all these books, she went up to the cash register, and what happened? Did they charge her $7 more, or did she get to take away $7 more? Remember, a discount is a decrease. So 5b minus 7. Okay, and what happened? She spent a total of $58. One thing that you can always look for is whenever you see a total, it should be on its own on the opposite side of the equal sign. So which of these matches? The bottom one. And I've got 5b minus 7 equals 58. Now I can use this equation to solve the aunt's question of how many books did she buy by solving it. I'm going to do that really quickly. We're not going to focus on that. So I'm going to do this pretty fast. So I would have to add 7 to both sides to represent her discount, taking away the discount. 5b is equal to 65, and 65 divided by 5 is 13. So she bought 13 books. But let's keep going on writing equations. It says Christine is saving money to buy a bike. She has $42 and is going to save an additional $7 each week. The bike costs $133. In how many weeks will she have enough money to buy the bike? So as I read the story problem, let's think about the big picture. So to begin with, what does she have? Well, she has $42. Now, what's happening past that? Is she increasing the amount that she has or decreasing? Well, it says she saves, so she increases by $7, and $7 again, and $7 again, because it says $7 each week. Remember that each part is a key feature that I'm going to put 7 and then the variable. Now, I chose W because down here in this problem right here, they used a W. But W stands for the number of weeks. So if she saved for 3 weeks, I'd do 7 times 3. All right. Now, is that all that she saves? Yep, she's not adding anything extra. And the bike costs a total of $133, so equals $133. Now, if you look at this equation, it doesn't match exactly this top row, because while it does have plus, I've got these in backwards order, so that's okay. Remember, if I break these terms apart, that 7 is positive and 42 is also positive. So I can just rearrange that as I put that in here. 7W plus 42, 133. On this problem, we're going to work in reverse. We're going to start with the equation, and we are going to end with a story. So when I look at this story problem, 26x, that means something's happening repeatedly 26 times. Or I'm going to see the word 26 and each tied together. Okay, I'm looking for that 26 and each tied together. And then it says minus 65, so that's a key feature. Something's going down by 65. and then is a total of 221. So let's practice this. So this first question says, today Rachel used $65 of her savings account to buy a bike. So is the amount that Rachel has going up or going down? Well, that's a one-time amount that she's using, and it's going down. That matches the 65 decrease in my word problem. So far, I think this equation matches, but I need to make sure and continue the rest of the way. She has been putting $26 into her savings account each week. Hey, there's my key word, 26 into her savings account each week. So that represents the 26x. After buying a bike, she now has 221, and there's my total. So this first one totally matches. But let's check the other ones. Rachel is saving money and already has $65 saved. That's an increase in the amount she has, not a decrease, because she already has it. She's not taking that away from her account. Okay, she's going to save an additional X dollars each week for 26 weeks. That right there, we're tying each and 26 weeks and X together. That represents 26X. And a total of 221. So most of this equation matches, but does all of it? No. 65 is going up instead of down. So this doesn't work. Rachel is saving money and already has $65 saved. Well, we just decided on the last problem that this going up means that it doesn't match the equation. So I'm going to cross that out. I don't even have to read any more. Finally, today Rachel used $65 of her savings account to buy a bike. That's going down. That matches. She has been putting X dollars into her account each week for 26 weeks. Each week, 26 weeks. That's my 26X. Hey, so far, we're matching up pretty good. After buying the bike, she now has $221 left in her account. Yep, that one works. And I'm definitely not going to choose that last one because I chose two of them. So I've got the equation 24x plus 12 equals 396. So in my story, I'm repeatedly doing something with 24 for each week or each something. And then I'm adding a one-time amount of $12 and getting a total of 396. So Goran works at a restaurant and earns X dollars per hour. Well, so far that's good. That X is in my equation, but that doesn't help me anymore. I'm just got to keep reading. Last week he received a $24 in tips. Now when I compare $24 in tips, I've got to ask myself, $24 in tips each? Did they use the word each next to the word 24? And the answer is no. Okay, that is a one-time amount. And if I have a one-time amount, that cannot have a variable. One-time amounts, okay, note to self, one-time amount, no variable. Well, if I look at my equation, 24 in my equation does have a variable. So this one is automatically out. Okay. Continuing to read. Goran works at a restaurant and earns $12 per hour. Remember the word each that I told you in the last problem? If it had the word each, that was automatically put an X by it. The word per is similar because I'm repeatedly adding 12. So this right here represents 12x. Well, in my equation, as I look at it, is there a 12x? Nope, just a plain old 12. So this one is out. Next one. Goran works at a restaurant and earns $24 per hour. Hey, 24x. That works so far. Last week he worked X hours and received $12 in tips. $12 in tips is a one-time amount. No variable. And as I look at my equation, does that work out? Well, yep. There is no variable next to 12. And he ended up with a total of 396 including tips. Perfect. That one works. Let's check the last one. Goran works at a restaurant and earns X dollars per hour. Last week he worked 24 hours and received $12 in tips. So X dollars per hour and 24 hours. We're going to tie those units together. That equals 24X. So far, so good. $12 in tips, there again is my one-time amount. With no variable, $12 does match that. He ended up with a total of $396, including tips, and that works. Okay, last but not least, let's try one more. So 18x plus 36 equals 234. Hey, this is my one-time amount. 36 is my one-time amount, and it is going up. 18x, hey, I'm going up by 18, up repeatedly. And a total of 234. So I'm looking for something that's going up repeatedly by 18, one time by 36, and a total of 234. Okay, let's find it. A printing company charges X dollars per banner. Well, there is something going up repeatedly. Let's see if we can see if it matches. There's also a one-time setup fee of $18. Oh, there's my one-time fee. This should have no variable. Does that match my equation? No, it doesn't. My equation, the 18 has an X, so this one's out. A printing company charges X dollars per banner. There's also a one-time setup fee of $36. So far, so good. There's my one-time fee. 36 matches. Kira printed 18 banners. So $18 per banner, 18 banners, 18x. Woohoo, that matches. She paid a total of $234, including the setup fee. That is a winner. A printing company charges $18 per banner. There's that word per, 18x. Great. There's also a one-time setup fee of $36. Yes, working out so far. Kira printed X banners. She paid a total of $234. That works out too, and that's a winner equation. A printing company charges $36 per banner. That's 36x. Does that match my equation? Nope, 36 should not have a variable by it, and so that one's out. All right. If you have any questions on your assignment to set up these equations, good luck on your assignments, and please reach out if you need any help.